I want to welcome our online webinar attendees, and also now I would like to present our next keynote presentation, Rick Deschamps. He's from Nicholson Construction Company. Thank you.
Thanks, Cassie. Good morning, everybody. I appreciate the opportunity to be here. Honestly, usually when I'm in this situation, I'm talking about a case history that has a whole bunch of nice, shiny equipment doing wonderful things, and I orchestrate a few pat-on-the-back moments and get things started here. But this one's a little bit different. I've been asked to talk about our industry and look back a little bit and then look forward a little bit, and so I'm going to try to do that. My background is a little bit different than probably many people in that I do have some experience on the design side. I was an academic for a while, and I've now been with Nicholson for about 15 years, and so I'm going to use a little bit of that experience and then the relationships I've developed to try to give you, I guess, my perspective. And so the warning that you'll get here is that I am going to share my opinion. So the idea here is that I want to talk about the challenges we face, I think, as a geotechnical industry, and maybe make some suggestions on how we can move forward to follow the future forward theme here. I think that as part of this, I'm going to have to make some fairly generalized statements, and so there's obviously going to be exceptions to what I'm saying, and I acknowledge that and accept that, and hope you can too. And then I think as part of this whole process, we're trying to generate some discussion and differences of opinion, so hopefully we can do that following the presentation. So as any geotechnical engineer, designer, I got to have a model to start off with, so I'm showing you my model, I guess, for an ideal model of our profession. And essentially, we've got the proverbial three-legged stool, very stable, with design, construction, and research working together to support our industry, geotechnics, infrastructure, quality of life, and all the things that go with that. Everything working in sync, all for the betterment of society. Very rosy, a romantic story, right? So the question I have is, how many people believe that this model accurately represents our current industry? Well, somebody, don't be shy. Not one person. Come on. I got one. Thanks, Terry. Thanks, Tony. All right. Well, I'm going to go through a couple of statements and ask a couple of questions here to maybe get us on the same track. So, civil engineering and geotechnical engineering are infrastructure-focused professions with a goal of improving the quality of life. Another hallmark type of statement I don't think anybody's going to disagree with, right? Next statement, everything that we do should lead to the optimization of or assured quality of a constructed product. Everything's a pretty all-encompassing word, isn't it? Right? But in the end, we're building infrastructure. It's all about some constructed final product, and that's why we're here, right? So I'll carry it a bit further, and I'll say that all design, all research should be focused on making construction more efficient, more safe, more economical, and more sustainable. No? I'm buying into it, huh? Couple questions. Are our design and research communities adequately connected to our construction community to accomplish the objective of improving the constructed product? Are we meshed enough in terms of research and design and consulting and construction to be efficient in what we do? Do we have trusting relationships? So again, as an industry, do we know enough about constructability, about certainty of execution, about limitations in the various techniques that we employ to accomplish this goal? And so I'll use a quote from the all-powerful Yoda. I think that there needs to be more communication in terms of what we're doing in order to be able to accomplish these goals. So I look back on my career, and I think there was 4 things that stuck out at me as I would say that have changed our industry in the last 30 years. And I'll identify those. And I think when I started, there was a lot more connection across those boundaries. The faculty and universities typically were not unfamiliar with construction sites and helping people solve problems. And those types of things are important. So I'll start off with the first one. Many years ago, the owners and construction managers decided to sever the responsibilities from the designers for doing the quality assurance. Early in my career, if we designed something, our technicians or our young engineers would be out on a job site doing the inspection, providing feedback. When a construction site change needed to be made, the designer was intimately involved with that, and that was done much more efficiently and much more, I guess, agreeably. Now the designers no longer get feedback, right? Because you have a third-party quality control organization handling it, and the designers are often kept in the dark. They don't know what's going on the job site. And it's a big problem because you lose that feedback loop. The other problem is with these quality control or quality assurance companies, they don't know the design intent, right? So they're trying to judge your work on a job site based upon specifications and drawings without knowing what is important or not. And there's a lot of information in the specification, and often there's only a few things that are really the important part. And they're just not capable of knowing that because they don't have the background in part of the design process. I think that because of this, the designers lose feedback on performance. Sometimes I've been with designers, we're driving someplace and they talk about a foundation system for a structure nearby. And in fact, they think what they designed was built that way, and some contractor came in with an alternative and built it, and he never even found out that it was different. Some other system went in place, right? There's just not that feedback loop. And because of that, if you're a designer and you're not going to get feedback, you're inherently going to be more conservative in your designs because you're concerned about how it's being built and what's being done. The second thing, I think, is the lack of practical funding for research. So early on, there used to be significant money coming from the Department of Defense, Department of Energy, Corps of Engineers would fund projects, state DOTs would have more money to fund projects. And so the faculty had real-life projects to be able to be involved with, right? The problem now is that the National Science Foundation is the most prestigious form of funding, and in that it's just fundamental research, right? They don't, in most of their programs, a generalization here, fund practical projects, and so it's science. And so in order to be upwardly mobile within an organization, get tenure, get promoted and all that, you're focusing on much more fundamental research and you're drifting away from the connection with the real world of construction, right? And so I think it's a challenge. You know, the reality is we're a very mature industry. There's not a whole bunch of really fundamental things that are necessary right now. We need things about constructability, about design in terms of feedback from the monitoring we're doing, equipment modifications, those types of things. So what's happened is the practical researchers, and there's a few, Rich Vinno is one, who's been able to create a market for himself by being successful in academics, but also stay connected to the construction community. It's just relatively rare. I will put a caveat out there that the National Science Foundation does fund earthquake-related stuff. It's more practical, but it's real because we get earthquakes all the time, making us remember about how important it is. The third thing is the transfer of geotechnical risk contractually. So the kinds of language that we have to look at now in terms of who's responsible is a challenge. So we'll see exculpatory language that is in a contract that's just absurd, right? It'll say things like, these borings are for information only. You can't rely on them for design. Literally. Or they won't give you the geotechnical report because they think you might interpret in a way that gets them in trouble later. So you're in a situation where you're supposed to give a lump sum fixed price, but their solution is you can take the borings after you win the contract. I just don't understand how that works because you're already fixed, and so what if you get information that's not consistent, right? But that's really the trend that we see. And so this starts really at the top and works its way down trying to manage risk. And you'll find you're in situations where that contractual language is actually more important than the cost of a job. You will be declined to get the work because you're not willing to take the risk or geotechnical risk. And then I think the last one is the evolution of design build. You can see it coming a lot more, and it's here to stay. It's going to keep on going. And in general, there is less conservative design and design build projects for a couple of reasons. One is you got to win the work, so you're going to have to design fairly aggressively in order to win the work. But also because of the risks I talked about before on the consultant side, they typically have led the consultants to, to be concerned about risk, and so the consultants design more conservatively, and so this ends up being a cheaper approach. Caveat to that is I would say that not under all circumstances is a quality assurance where we'd like it to be as an industry, right? I think the majority of times it is, but there'll be other times where, if you want to take the foxes watching the hen house or not, there's certain situations where you could get into where maybe the quality isn't what you would like to see it be, or the quality assurance isn't there that you would like to see. Now, there's some firms are comfortable in a design build environment, and there are many that are not. And part of the reason is that it's working for a contractor is much different than working for an owner, right? Working for a contractor, the contractors are built on fighting for their there's much more conflict in a contractual environment than there is working for an owner, and so they're putting the designers in a much more challenging situation that's not always comfortable, right? The good thing is that these consultants or designers that are working in that environment are getting some construction experience. They're getting some relationship to or benefit from the construction environment. I wouldn't say it's universally true, because I've been on design build jobs for once the construction started, the designers kept at bay even on those jobs, so it's not always the case, but at least there's some benefit there. So I'm going to come back to the model again. So this is a model from a contractor's perspective, right? And it's not that the designers and the researchers are completely out of the picture. It's just it doesn't feel like there's enough involvement, right? And so we're contractors yelling out for a little bit of help, and we'll get responses like, "Sorry, I have to worry about liability," or "Sorry, I have to worry about funding." And this is a little bit facetious, but there's a lot of truth to it, because it's true. And these are real commercial risks that the consultants have to worry about liability, right? They have to worry about the concerns for that. But again, if you don't stay close to that constructed product, what is your relevance of the work that you're actually doing? Because in the end, we're here to build stuff, right? And it's the same with funding. If you want to be upwardly mobile in a university environment, the prestige of NSF is more important than the ability to do work. Unless, like Rich said when he's sitting over here, well, I made it important. I had to do it myself. So I'm going to rely on somebody who has far more credibility than me to provide some words of wisdom. And these are not real recent. And this comes from Words of Wisdom, Ralph Peck, from its Norwegian Geotechnical Institute publication. And first one is, construction deserves more attention in design. Our permanent structures are too often designed as if they come into existence without the necessity for being constructed. Unhappily, far too much that we write is not worth reading. The prestige assumed to be associated with authorship results in great pressure to publish. The academic climate encourages finding a subject for investigation that can be pursued at the desk or in the laboratory until all aspects have been exhausted. The subject is likely to be chosen for more convenience than for significance. The most fruitful research grows out of practical problems. In my view, nobody can be a good designer, a good researcher, a leader in the civil engineering profession unless he understands the methods and the problems of the builder. Again, not a new problem, but one I think that we've got to be able to deal with if we're thinking about the future. So some suggestions. I think that as individuals, we have to recognize that if we're going to stay relevant, we've got to understand what construction is about. We've got to be prepared to get out there and be a part of the final product that we're trying to put in place. And so as individuals, whether you're a researcher, a consultant, or a young person coming out of school, I think you have to make it a focus to be involved in the construction process and the challenges associated with that. I think DFI does a good job of trying to round up across a multi-diverse membership. We have a lot of contractors, suppliers, consultants, could use a little bit more researchers involved, but they are trying to go for a diverse membership so we can have these kinds of dialogues. They're forcing this discussion to take place because they know that it's important. They also have some industry-focused funding, right? There's seed money in projects that they support that are practical, that young faculty can get involved with. And now they've got a program in place for international internships to get young people on construction sites. ADSC has had 2 or 3 faculty workshops. I think that DFI, ASCE, and everyone else ought to jump on board and support this type of effort and expand this type of effort so that the faculty can be made aware of real construction. And I think the consultants should be invited and to be a participant in that. I think there's the amount of money that it would take to do that, because a lot of people would be willing to volunteer, is not that significant, but I think it does have the potential to change things. I think that many contractors do, but I think that as many contractors as can get to know people in the universities, go to the universities and present real case histories. Talk about construction. Talk about the problems of construction. Don't be always patting yourself in the back. Tell them about the things that went wrong so that they know that's normal business. And finally, if you're a designer, reach out to the contractors and talk to them, multiple contractors, and use the advice, because we still see specifications asking for things that are impossible, right? And sometimes I think the designers know it's impossible, but it's just a way to pass the responsibility, right? And so that's not how we want to, interact or work as an industry. A couple more comments here. Find a mentor, be a mentor, right? I think there's no faster way to navigate the geotechnical world than to be with a committed mentor, somebody who's going to support you. You think about this whole Chicagoland area. If Ralph Peck hadn't come here for the subways, right? If Clyde Baker hadn't settled at STS, and more recently Rich Finno coming here to Northwestern. Very powerful mentors have impacted numerous people, right? And so very important. And I think that I'd like to acknowledge Jerry Leonards and Tom Richards, who did that for me. And finally, I think it just, as you take the initiative to be a mentor, you could be mid-career, but somebody coming up junior would still benefit from your input. So do that. I think it's really important. Excuse me. And then finally, some final thoughts. Their changes have been significant between 20 years ago, 10 years ago, and today in our profession. And I think the changes are going to be significant in 10 years from now, and some of the time frames we talked about were even greater than that. So I think we have 2 choices. We can look for and adapt or maybe influence the changes that are coming, or we can expect things to stay the same. And I think the latter option is going to lead to disappointment and maybe irrelevance of the work that we do. So I implore you, please find ways to become familiar with construction. Thank you. Anybody want to throw darts or tomatoes? I'm sorry.
Dr. Jim, what you said was good, but unfortunately there's not too many professors here. The contact between the university's professors in geotech and the real world is somewhat like trying to put a bridge from the United States to Europe over the Atlantic Ocean. They don't know, the new students getting masters, PhDs in geotech have no knowledge of ground improvements with most universities. They don't know anything about helical piles. They don't know anything about aggregate piers. You can ask them 10 questions on advanced geotech, and these guys are completely illiterate on it. They don't have anything because the guys teaching them, when they got their doctor's degree 20 years ago, they still use the same notes. They don't understand that the state of the knowledge of engineering progresses irrespective of the fact that they didn't learn anything new. So there's a big chasm between the educators and the constructors.
I couldn't agree more, but I was trying to be tactful.
Right.
Well,
Thank you. So we're gonna, we only have time for one more question.
If you look at the roster here, the majority of the people here are practitioners. They're not professors. So the problem is, Dr. Rusper is a professor, but the majority of people aren't professors. So the people that are teaching geotech are like the guys that read the book by Arnold Palmer on how to play golf and stay out of the sand traps and out of the water hole 30 years ago, but they never figured out how to use a new club. So
Thank you. So I have one question. So what should an undergraduate or graduate degree provide the geotech engineer of tomorrow?
Well, I think independent of the degree, the most important thing a person can learn is how to communicate, right? You got to learn how to talk. You need to learn how to write. You need to know about interpersonal communication, independent of everything else, because every issue we face in this world, independent of geotechnical engineers, almost always comes down to ineffective communication, right? So communicating clearly, getting confirmation and feedback, all those things are extremely important. So that's one. I'd say for geotechs, it's geology, right? So, you know, unless you're working in a local environment, let's say Chicago is home, you know geology of Chicago because Peck identified it a long time ago. But if you're working across the country, you don't have a framework to interpret anything if you don't know the geology, right? And the only way that you're going to know that is to study the different modes of deposition that we have in the geomorphology or superficial geology. These are the keys to understanding what a boring means, right? Whether it makes sense to draw two lines between two borings or not. And unfortunately, in many of our programs, the ability to take geology is no longer is obvious. I mean, no longer is readily available, but it's extremely important. And if you have to learn it on your own, you got to learn it on your own. I mean, but it's important. Undergraduate, to me, undergraduate is about learning the language, learning the vocabulary of civil engineering, right? I think a broad degree in undergraduate is important, so because everything we do as geotechs is interact with everybody else in civil engineering, and it's good to know the language, what their problems are trying to solve, and those types of things. And in graduate school, to me, it's getting to a technical level to be able to learn, start learning, right? Very few things. You learn very, very specific things in university, or you learn what's in textbooks, and those aren't the things that you're going to apply necessarily when you get out there. But you got to get to a technical level where you can read technical information and understand it efficiently. And so to me, it's getting to that level.
Thank you very much. Thank you for our speaker.